their first appearance in aircraft flight control during World War II. That time, they were used to control various secondary systems. Hydraulic began to play a larger part in the crucial functioning and safety of airlines, helicopter, and high-performance military aircraft. In modern aircraft, hydraulic are used in primary flight control, flap sled drive, landing gear, nose wheel steering, thrust reverse, spoilers, rudders, cargo doors, and emergency hydraulic-driven electrical generator. When designing an aeroplane, there are a few factors that must be considered, which are pressure conditions, both internal and ambient, temperature extremes, weight, speed, materials, reliability, fluid compatibility, legs, cost, noise, and redundancy.
There are 7 design stages: problem definition, conceptual design, preliminary design, design detail, flight testing, critical design review, and certification. There are 4 materials used in construction process. Number 1, viscosity, chemical stability, flash point, and fire point. Number 1, vegetable-based hydraulic fluid, has alcohol odor and is generally dry blue. Natural rub seal are used with vegetable-based hydraulic fluid. Number 2, mineral-based hydraulic fluid is processes from petroleum, has an odor similar to penetration oil and is dye red. Rubber seal are used with petroleum-based fluid. Number 3 is Kadir. This is non-petroleum-based hydraulic fluid. This fluid is fire-resistant, clear purple liquid having a good low temperature operating and low corrosive side effects. Next, method of process. Hydraulic is a method of transmitting power through pipe and control using liquid as an operating medium. Liquid are most practical purpose, and this fact enable movement to the transmitter through pipelines over great distance without loss of time or motion. Next, maintenance and inspection of hydraulic system. Point number 1. Servicing is a routine inspection to correct quality of hydraulic fluid in the system. Point number 2. It mainly involves cleaning of filter and element of cleaning the filter and placing the element. Point number 3. Maintenance consists of inspection, replacement of component part, and testing. Proper precaution must be strictly observed to prevent injury and damage. Point number 4. In the hydraulic system, O-ring have their service life, so it is replaced before expiry.
So first, I will touch about the aircraft hydraulic system accumulators. As we can see in this figure, the accumulators is still separately divided into the 2 chambers by a synthetic rubber diaphragm. The upper chamber carries fluid at system pressure, while the lower chamber is charged with the nitrogen or air. The cylinder types are also used in a high-pressure hydraulic system. Other than that, the top part accepts fittings to connect the pressurized hydraulic system to the accumulators. The bottom part is fitted with a gas servicing valve such as threaded valve. As we can see in this figure, bladder is installed through a large opening in the bottom of the sphere and secured with a threaded retainer plug. The ram air turbine, or also known as RAT, is installed in the aircraft to provide the electrical and hydraulic power if the sources of aircraft power are lost. Ram air turbine is used to turn the blades of a turbine that operates a hydraulic pump and generator works. The door is hinged and allowing the assembly to be extended into the slipstream by pulling a manual release in the flight deck. Thus, in some aircraft, the ram air turbine automatically deploys when the main hydraulic pressure system fails and electrical system malfunction occurs. An actuating cylinder is to generate energy in the form of fluid pressure into the mechanical force and action to perform work. It is used to pass on the powered linear motion to some movable object or mechanism. Actuating cylinder contain of a cylinder housing, more piston and piston rods, and some seals. As we can see in this figure A, the fluid pressure enters the part at the left and push against the face of the piston and forcing the piston to the right. The fluid is forced out and of the fluid part. At the same time, the moving piston pulls air into the spring chambers through the vent hole.
Next, are the issues that related to construction engineering process during the construction of hydraulic system in the aircraft. However, any of these compartments could fail, not to mention the added risk of failure due to human mistake and pure maintenance procedures. If your system malfunction, you must understand why it malfunctioned, how to locate the problem, and how to keep it functioning well in the future while keeping workers safe. There are 4 common causes of hydraulic system failure. The first one is air and water contamination. This is the major causes of hydraulic failure, which account for 80 to 90% of all hydraulic failures. Next, temperature problem. Poor heat dissipation is the usual suspect behind heat buildup, while environmental factors most often cause too cold system. Number 3, fluid levels and quality can be caused by low fluid levels and inadequate filtering. Fluid contamination can trigger temperature issues. Number 4, human error by fault installation, incompatible parts, improper maintenance or usage. Avoid hydraulic system failure by following the instruction. First, follow specification by trace the most common hydraulic system issues and always double check specification to ensure the parts can function. 2. Consult the professional to discover what they recommend when installing new parts. 3. Perform maintenance. Review your daily, monthly and annual maintenance procedure to ensure every aspect will cover of the system according to the best maintenance practice. Next is accident. The first one, A332 Karachi, Pakistan on 4 October 2014. The accident happened when the fracture of a hydraulic hose was followed by dense fume in the form of hydraulic fluid mist filling the aircraft cabin and flight deck and caught fire. Second, DC-10 in USA City on 19 July 1989. The accident suffered a sudden explosive failure of the tail mount engine and the complete loss of hydraulic so that the aircraft could only be controlled by varying thrust on the remaining 2 engines. Aircraft had an emergency landing led to the destruction of the aircraft by impact and fire. Next, B743 Tehran, Mehrabad, Iran on 15 October 2015. A experience of the affected engine thrust and uncontained failure. The eject debris caused the almost simultaneous failure of the engine, loss of multiple hydraulic systems and all the fuel from one wing tank. Lastly, B763 Warsaw, Poland on 1 November 2011. A Boeing 767-300 landed with its landing gear retract after declaring an emergency in anticipation of the possible consequences.
Recommendation. There are 5 basic safety practices that need to be followed when doing system maintenance. The first one is wear safety equipment. The second one is power down systems. Third one is be mindful of location. The fourth is use safety locks, and the last one is use caution around running systems. Second recommendation is how to maintain and operate GSE equipment. The first one is contamination. Any hydraulic GSE maintenance plan should start with a robust contamination control program. Second one is monitoring. Regular fluid monitoring ensures that the fluid fulfills the fluid. And the last one is fluid compatibility. Different wetted materials are required in hydraulic GSE equipment for petroleum-based and phosphate as the hydraulic fluids. Aviation hydraulic is one of the few applications of hydraulic systems that can be called mission critical. The rationale is straightforward. Many human lives are on the line. Hydraulic power is vital for smooth and safe flight because of these properties. However, this does not imply that aircraft hydraulic systems are without flaws. In fact, preventative maintenance must be performed on a regular and systematic basis for any hydraulic system to function properly.